Okay, so today is beginner OSPF part 3 of 4. So that means we got today and then next week left. It's going to be multi-area OSPF. In the first two meetings we did single area OSPF, so today we'll do multi. We got 7 routers into our topology. You could see in the middle section we got a triangle topology. That's the same as our previous sessions. And then what will happen is we're going to be configuring, well, first we're going to configure the middle part, and then we're going to configure these edges and see what happens. So these are going to be in a different area. So before we actually do that, we're going to go through things like explaining why you need multi-area OSPF. We're going to show you what happens if you're in a single area OSPF and links break. And we're going to actually start off with a little bit different. We're going to configure that center triangle there. Instead of area 0, we're going to configure it with area 1, just so you can see that we can actually get a working network without area 0. But things are going to change when we add other areas. We're going to look at the LSAs after we set up multi-area OSPF. We're going to look at the new LSAs we're going to get, specifically the summary LSA. We're going to look at what an ABR actually does by looking at its database. And then if we have time, we'll do summarization between areas, and that's taking multiple routes and squeezing them into one route. And then we may not get to this, but just in case we're really fast, we'll get into stubs and not so stubby areas. So first of all, let's just make sure we can ping from one router to the other. So go on R3 and ping 255.255.255. So you're going to go on R3, ping all 255s. And you should get a reply back. Very useful tool to have. So on that ping, Jerry, it's going to be all 255s. Okay, so you have a ping coming back. Those are pings on R3 to R1, R3 to R4, R3 to R5. So when if you have pings going, that means that you're pretty much assured that the rest of your topology is also set up correctly. And to be 100% sure, we could go on every router and do that, but that's probably overkill. So we're going to set up OSPF on the middle triangle there. We're going to go on R4 first. And the reason we're going to go on R4 first is because all of its interfaces are safe to configure in a single area. So versus R3, the difference with R3 is going to be our border router. It's going to split two areas. So there's going to be an area on the right side, and there's going to be an area on the left side. So we can't do a network all zeros on this one. Well, we could, but just to make it simple, just assume that we can't just throw all these things into one area. Now R4 over here, this interface and that interface and all the loopbacks, they can go in a single area. Not a problem at all. So make sure you're on R4. And as we go on R4, we go enable mode, conf T. Please mute your mic. Thanks. And it's going to be router OSPF 1. And if we want to throw everything on R4 into OSPF, who remembers that command? And you could type in the chat window there. Yep, pretty close. Network all zeros. Yeah, all zeros. Now, it's either all zeros or all 255s. Both will work. Area. Now, usually you do area 0. In our case here, we are going to do area 1. So network all zeros, throw it all into area 1. And after you do that, always verify that OSPF started and also the correct interfaces are in OSPF. You have two options here. Show IP protocols. It's going to show you OSPF. What you're looking for is you see your router ID here. You also see that you popped everything into OSPF. So most important things. Let's change that router ID. I don't like that router ID. So go back into OSPF and type in router ID 0004. So router-ID. And you'll probably have to clear IP OSPF process to kick everything over. Reason we're going to change this router ID is we know that the highest loopback will become your router ID, and that can be kind of a weird number, so that means I'd have to remember 100, 100.3.1. If I change my router ID manually to 0004, that just makes it a lot easier when I look at the database and I look at routes where things are coming from. Okay, so now if I do show IP protocols, you'll see that my router ID is 0004. And then to verify which interfaces are actually in OSPF, you could do show IP OSPF interfaces BR. BR stands for brief. And you'll see I've got both my fast Ethernet interfaces, fast00, fast01, and loopbacks 0 through 4 in there. So everything's chucked into OSPF. So Jerry, I see you struggling a little bit. You may have loaded in something with OSPF already configured because you've got a virtual link in there. So do me a favor, go on R7 and show IP protocols on R7. Yeah, so you got the one with OSPF already running, but that's okay. Here's what you do. Go on all of your routers and do no router OSPF 1. No router OSPF 1 on all of your routers, and then just go back to R4 and throw all your interfaces into OSPF. So most likely what you did is this. You inhibited resources, you went to topologies. You probably did this one, basic OSPF diagram. So it was either that one or the BGP one. No router OSPF 1. So router OSPF 1 is what you use to start it. No router OSPF 1 is what you do to kill it. Okay, so while you're doing that, the rest of us are going to continue forward. So everyone go on R3. Now R3, we're going to put that link into OSPF, area 1, and this link into area 1. We're going to leave the fast00 link alone for now. And this is going to be similar for what we're going to do on R5. R5 is going to be, we're going to leave that fast 10 interface to the right alone. Okay, so let's go to R3. And as always, or what you should do is, before you configure any type of interfaces in OSPF, always do a show IP interface brief just to give you a reference of the interfaces and the IP addresses. So we'll go conf t router OSPF 1 router ID. Let's make the router ID 0003 just to make our lives easier. And then we're going to throw fast01 into OSPF. We're going to match it exactly. And network 10, 10, 34, 3, 0000, area 1, and you can hit the up arrow and just change the 34 to a 35, that's going to throw fast 10 into area 1. And you can hit the up arrow again and change that to the loopback address, which is 3333. Right? Always use those keyboard shortcuts. Makes things a lot easier. So you're throwing in everything highlighted in red. So you're throwing in this link into OSPF. You're throwing that link into OSPF. And you're throwing the loop back into OSPF as well. All right. Steve, if you can share your screen so everyone can see what you're typing. Okay, and of course, just like before on R3, show IP OSPF interface brief. And you can see you have got your loopback, fast10 and fast01 in OSPF. Okay, so I'm going to give you guys a couple minutes to catch up, because I know Jerry's still on, just finished router 4. Mark looks like he's just booting up. Chris looks like you're pretty much caught up. Benedict's screen is all, I don't know what's going on there. So I'll give you guys a minute to catch up. Router 3. So go on router 3. And you're going to put these interfaces into OSPF. So you have a fast 01, fast 10, and the loopback. And just type in the chat window when you're all caught up. Okay, so Jerry, you popped everything in area 0. Everything should be area 1. Area 1. Okay, so you have two routers connected. You have R4 and R3. You should be able to ping 4444 from R3. That's because they're in the same area. If you show IP OSPF database, you'll see that your type 1 LSAs 0003, 0004. We have that because we changed our route ID. It makes our life a lot easier. And we have a network link state. Remember, this is the DR that does this. And you get 1 per link. So this is in between router 3 and 4. All right, so 2 routers talking just fine. Now we're going to go over to R5. We're going to put the left links into area 1, and then the right link we'll leave just for now. So R5, show IP interface brief. Router OSPF 1, we'll do our router ID first, 0005. And then we'll do our network statements. Let's see, 10, 10, 45, 5. Sounds about right. 0000, area 1. Hit the up arrow, change the 45 to a 35. I think we should be okay there because 101056 is on the right side. Hit the up arrow again and change that network statement to all 5s. And when you're done, show IP OSPF interface brief. You'll see that you got your 3 interfaces into OSPF. That's great. Show IP route OSPF. Shows all the OSPF routes. So you should be able to ping all 3s, all 4s. So right now, inside of this triangle here, do we have full reachability inside that triangle that I have highlighted in red? Well, can you go on any router in that triangle and ping the loopback of the other routers in the triangle? Okay, so if you set everything up, everyone in area 0, the appropriate interfaces in running OSPF, you should be able to ping all the loopbacks within the area. You should be able to ping the links, all the addresses on the links in between the areas. So you have a fully functioning network in that triangle, and everything is in area 1. So you don't need area 0 if everything's in the same area. So those 3 routers, if you just left them at area 1, you would be perfectly fine. The only problem is we're going to add other stuff to it later on, which is going to change everything. So let's run a debug. Let's go to R4. So the debug we're going to run is debug IP OSPF. And let's do, what's a good one here? SPF. Debug IP OSPF. SPF stands for shortest path first. That's the algorithm that OSPF uses to find everyone else. And nothing's going to happen because your network is stable. As long as the network is stable, we don't need to do any type of algorithm. We don't need to find neighbors, find shortest path, or anything like that, because nothing's changed. So now let's break the link down here. So we're gonna kill that link. So between router 3 and router 5. So let's do it from router 3 side. We're going to kill fast10. So make sure you're on the right router. Interface fast10. And just shut that guy down. Go back to R4 and you can see lots of stuff is happening. Whole bunch of crap happened on router 4. Well, whole bunch of crap happened everywhere. Router 4 we had the debug running, so it's more visible. Okay. So we see all this stuff being generated. Let's take a look at one of these things. So we broke the connection down there, and you can see this line here, OSPF, initializing to run SPF, rebuilding the tree. So what this means is OSPF has detected that there's a problem in our network, and so it's basically saying, okay, well, there's a problem. Let's find if there are better paths to networks like 100, 100, 2.1, that's the loopback. Let's find a better way to 4444. 1010, 45.4, all these links here, all these IP addresses, OSPF said, okay, let's see if there's something better. So this is very processor intensive. Let's see if we actually got this processor working here. show proc CPU history. Yeah, nothing too much, but we didn't kill it. We had like a little blip a couple minutes ago. So in the single area, a change happens, all the routers in that area will be notified. They're all going to run their SPF algorithm. They're all going to go nutso for a couple seconds, and things eventually are going to calm down. Now if we go back to R3, hit the up arrow and do a no shut, so turn that interface back on, you'll see that R4 is going to freak out again, detected a change, and it's going to look in its spanning tree, it's going to recalculate everything. And eventually everything's going to be okay. Now all we have is a 3 router network. Imagine if this was a 50 router network. 50 router network, one link breaks, the other 49 routers or all 50 routers are going to go nutso for about 10 to 20 seconds. What if you have 100 routers? Well, even more crazy. So you can see that in certain cases OSPF is, if you have things breaking, things coming online, links breaking, not a good, to leave it at the default setting might not be the best thing. Now right now these links are 100 megabit. So this link here, that's 100 megabit. So imagine if these links inside this triangle, imagine if these were satellite links, where each megabyte costs you $8. Now you may be thinking, well, I would never run OSPF over a satellite link. Well, you may have to one day. And you may also be saying, well, what data out there costs $8 per megabyte? Well, let me show you. Let me show you how much BGAN costs. So BGAN is a portable satellite system that you can have out there when you're camping or wherever in a war zone like I've been. And MRSAT, let's do this. Okay, here we go. Okay, so these are BGAN terminals. They hook up to your laptop, and speeds kind of suck. 464K, you can get 512K, and so those are the terminals. They have most of them have an Ethernet port. Some of them have a USB port. This is just a terminal, and then you have to buy airtime, and the airtime is pretty hellacious. BGAN service. Here we go. Let's take a look at how much BGAN service is. Here you go. Prepaid service, 63 megabytes. We are talking about $5.95 per megabyte. It goes down if the more megabytes you buy. If you go up to prepay for 1200 megabytes, it goes down to $470 per megabyte. Still a lot of money, but so in cases where you're using slow links, there may be a situation where you're going to tune OSPF so that they're not all on the same area. All right. Okay, so now what we're going to do is we're going to configure everything on this side to be a different area. Oops, kind of messed that up. So everything in that circle to be in a different area, we're going to call it area 2. We're going to call it area 2. So this is going to be a lot faster. We're going to go on R3 and pop fast 00 into OSPF. So R3 fast 00. And the way we're going to do this, we're going to do it a different way. So R3 show IP interface brief fast 00 is the one we want. Here's how we're going to do it. We're going to use the direct way of putting an interface into OSPF. We're actually going to go inside that interface fast 00. I'm going to type in IP OSPF 1 area 2. That's it. It's basically saying run this interface in area 2. This command does the same thing as that network command. In fact, I like this command a lot better. So IP OSPF 1 area 2. And you're going to do that on fast 00. Okay. So mark, exit out of there and show version. And what's your version number there? .12.4T. You've got 12.3. So that's why I recommend everyone use 12.4T. That's in the FAQ. But yeah, so do it normally, you'll be okay. All right, so R3, we pop this interface into area 2. And now it's going to be easy. On R1 and R2, just do the Hail Mary, throw everything into area 2. So R1 and R2, throw everything area 2. That's the network all zeros command. So after you popped R2 and R1 into area 2, let's go on R2. Show IP OSPF interface brief. You'll see that everything's in area 2. Show IP route OSPF. We don't have much in our routing table for OSPF. So 1.1, that's the loopback for router 1. 10.10.13, that's the link between routers 1 and 3. So you see that. Okay, that's cool. We have a loopback over here. That's cool. But we don't have anything in that center triangle. Right? We have no route for that center triangle. So show IP route OSPF. You've already done that. Right? If you just do a show IP route, we have nothing, no funny business here. We don't have, if you show IP route 4444, it's not in there. So you cannot get into that center triangle. So the reason for this is if you have multiple areas like we do, we've got a area 1 there, and we've got an area 2 on the other side. They can't talk to each other. We cannot get from area 2 to area 1. Because the job of area 0 is to tell the other OSPF areas, it's the connectivity, it's the backbone area. Now as long as you have a single area, hey, whatever area you want, that's fine. But in this case, we popped the center area into area 1, and we could see that that decision hurts us in the future if you try to do other areas. Let's see how things look on R3. R3's got 2 different areas in it. So if we go to R3, show IP OSPF database. Let's see how the database looks like. You could see it's split-brained. We've got the information about area 1 at top. We have information about the area 2 on the bottom. But we see the type 1 LSAs, the router LSA. We see the network LSAs, but we're missing something very important. We're not seeing what's called the summary network link states. The summary network link states is how you get to another area. So if you can't get to another area, you're not going to have connectivity to that center triangle, and the guys in that center triangle can't get to the left. So we have an island here where people kind of can't talk to each other. So who has an idea of how we can fix this? We've got area 1 and area 2 can't talk to each other. R3 is supposed to be the area border router. He's supposed to translate signals in between the left side and the right side, but he's not. So how do we solve this? So we got ourselves into this situation by putting everything in the center triangle as area 0, or as area 1. Kind of gave it away now. So what might I want to do to that center triangle? Make it area 0. Yep. Okay. So let's go back to R4. So there's a couple ways of doing this. The easiest way, I think, is router OSPF 1 on R4. Hit the up arrow a bunch of times until you get to that network statement. And let's see if we can just do this. So you hit the up arrow until you get to area 1. That network all zeros, area 1. And just delete the 1 and turn it into a 0. See if that works. And we still have the debug running on R4, and you can see everything just went nutso, right? And so we're on R4, show IP OSPF interface brief, And you'll see that everything now on that router is area 0. So that's good. So R4 was easy because everything's area, we want everything to be area 0. Now we're going to go to R3. I'm going to be systematic here. And you can see you're starting to get this error. Mismatched area ID. And the reason for that is one side is area 1, the other side is area 0. And it's basically saying, dude, something's messed up. But we're going to fix that, so not a big deal. So conft router OSPF 1. Hit the up arrow a bunch of times, and you're going to get to a network statement. So between routers 3 and 4, it's going to be network 10.10.34.3. Right? So it's area 1, just hit the backspace, change the 1 to a 0. And now you're going to hit the up arrow again until you find 10.10.35. Change the 1 to a 0. And just verify that everything's working by show IP OSPF interface brief, and you'll see that you've got 2 links in area 0. Oh, we have to do our loopback as well. So router OSPF 1, network 3333, all zeros, area 0. And now when we do our show IP OSPF interface brief, you'll see that you got 3 links in area 0, and the faster 0 link to router 1 is in area 2. And we're going to finish it up by going to R5, or finish it up for this triangle. Show IP OSPF interface brief. So this is our current picture. We've got 3 interfaces in area 1. We're going to change that to make 2 of them as area, or actually 4, 5, 3. We're going to make all of this into area 0. So pretty easy. Router OSPF 1, and if you want to do it manually, network 5555, network 10.10.35.5, and 45.5. And yes, you're getting those error messages, but as soon as you type all that in, your error messages will stop. So I've been watching all of you, well, all of you who have your screen shared, typing things out. And I know that a lot of you are kind of starting off CCNA, CCNP type stuff. How many of you are having trouble remembering which router you're on, remembering what link you're configuring? So what I mean by that is, if you're on R3, does it take you a couple seconds to kind of remember that, okay, the fast 1.0 is 10.10.35, or, you know, kind of like, where am I? How many of you have take a couple seconds to do that? All right, so what's happening here is when you're beginning, all of this is new, so your brain is working overtime. I see that some of you, the commands aren't completely stuck in there yet. Your muscle memory hasn't been working. So what happens is, after you learn, if you do the command a couple times, you're going to learn that, okay, if I want to throw an interface into OSPF, it's this command. If I want to change the router ID, it's this command. So right now your brain is working 100% trying to remember those commands, and there's no brain power left to remember other things. So it's like you're juggling and you've just started to learn how to juggle and things are dropping. As time goes on, when you get more practice, you will find that, and this happens to all CCIE guys, well, I hope all CCIE guys, like I can leave this console window up, blocking everything, and I got no problem. I don't need to look at this anymore, because I know what the commands are, I know what interfaces to go on there. It just, with practice you could do all this. It's kind of like people play chess a lot. Eventually you can play chess blindfolded. So it will come a day after enough practice where you'll look back and go, wow, I can't believe I was like that back in the old days. Okay, so everything in the center is area 0. Now if we go to R2 and we show IP route OSPF, you're going to see that you have a lot more routes. You can get all the way over to R5's loopback. Now if you show IP route OSPF, you'll notice that you've got O routes. So you have an O route for all ones. You have an O route for 10, 10, 13. And if you look at your diagram, those two routes are in your same area. They're all in area 2. Now, if you look at these, you're going to have OIA routes. IA routes mean inter-area. They came from outside of your area. In this case, it came from area 0. And this kind of makes sense. Now, if you just want to see the IA route, so what you could do is show IP route OSPF pipe IA. And that's just going to get you that list. So show IP route OSPF pipe IA just cleans everything up. Yeah, interstate, exactly. Okay, so just looking at some of your screens, I've got a bunch of loopbacks, 100 that you guys don't have, but we won't worry about that. That's okay. So let's see what's different on R3 after we popped area 0 in here. So if we show IP OSPF database, you'll see something different. And that is this. You now have what's called summary network link states. These are the type 3 LSAs. This you only get if you are an ABR, area border router. That means you sit between two areas. In this case, you're between area 2 on the left side and area 0 on the right side. What this guy is doing, he is translating information. He is basically saying, if you need to get to 1111, you hit me, 0003. If you want to get to my friend, go through me. without the summary network link state, you don't get from area to area. So now let me show you something cool. Go on R2. We're going to do a debug IP OSPF SPF. Right? This is the same thing we did on R4. I think R4 probably is still running. So remember before we started the debug on R4, we cut the link at the bottom of the triangle and everything went nuts. Right? We're going to do the same thing, and we're going to see if there's a difference between spanning tree, between R2, which is in a different area, and R4, which is in the same area. Right? We want to see if there's a difference, if doing the multiple areas really helps us or hurts us. So now we're going to go to R3. We're going to cut this link between R3 and R5. Right, so show IP OSPF interface brief. The link between 3 and 5 is fast 10, so interface fast 10. Shut. R4 went nuts, right? R4 went completely nuts. Things are going crazy. Armageddon happened on R4. So R4 had a couple, whoa, that's a lot, right? Lots and lots of pages happened on R4, right? Just a whole mess of stuff. Okay, we take a look at R2. R2, not too much. We still have some stuff going on, but really, it's a lot less. So why is this? Well, the reason is the whole point of an ABR, okay, he passes information from left to right, right to left, between areas. Another function he has is R2 and R1, all they have to know is how to get to R3. R3 is hiding a bunch of the stuff behind it, R4 and R5. Right, so everything happening in the area, that's kind of like its little domain. We don't really need to tell the rest of the world about all of our problems. Similar, kind of like if you have a family, I'm assuming all of you have families of some sort or another. You have brothers and sisters, mothers, fathers, sons, children, all that stuff. Most likely, I'm going to guess that not everything in your home is perfect. You have little arguments, things happen, things break, cell phone bill is high, your daughter's dating, strange man, all this stuff, right? But that stuff stays inside. That stuff stays inside of your family. In OSPF, all of your problems, most of your problems stay inside of your area. Links break and stuff, that's fine. Inside of our area, we go crazy. But then when we talk to other areas, we're calm. Don't need to worry about too much. So R3's job is kind of like the father of the family. Right? So let's raise that link back up. We'll go to R3 fast 10. Make sure you're on the right device and do a no shut. So let's go back to R2. You'll see that some stuff happened, but about a page worth of stuff. versus going on R4, R4 is still going. R2 is basically done. So if we show IP OSPF database, R2 has the type 1s. It's the type 1s for its area. So router 3, router 1, router 2. We didn't do the router IDs on the other two, but that's okay. We got 2 network link states, so two links. Everything else is a summary network link state. So you see the LSA for router 5's loopback, it's in a summary network link state, a type 3. All of these are basically saying, hey, you're going to get to router 3 if you want to reach any of those. Let's see if we can get some more information. You can always show IP OSPF database. That will show you the whole database. If you would just want to see the summaries, you could add the word summary at the end. So show IP OSPF database summary. This will give you detailed information. So you'll find the one that says, the one for all threes, 3333. All right, so it's saying if you want to get to 3333, you're going to hit router 3. So that's the router ID of router 3, 0003. You see this sequence number? There's a 3 at the end. That means that this thing has changed 3 times. So it came up, that's the first time. We killed the link the first time, that's sequence number 2. And then we did it a second time, that's sequence number 3. So there's been 3 major changes on our network that has caused this thing to go crazy. Now if you notice down here for this 444 link, he probably has a sequence number of 1. See that? So up here 3, up here 1. So why is that? Well, if we take a look at our diagram, what was the link that we were killing in our little triangle there? What was that link? It was between which 2 routers? Three and 5, yep. So we were messing around with that link. So if you're screwing around with the link between 3 and 5, how you get to the loopback of router 3 and router 5, they're going to change because you were going through 3 and 5 before, now you have to go the long way around, 3, 4, and 5. Now the loopback on router 4, which is up here, if I'm looking at it from, let's say, router 2's perspective, or actually any of these routers' perspective, does it really matter if I'm killing this link down here? Does it really affect this link at router 4? No, because if you look at it from router 2's perspective, it's going to go normally router 2, router 1, router 3, router 4. If I kill the link 3 to 5, it's still going to go 2, 1, 3, and 4. Router 3 is going to hit directly to router 4 for that loopback. Router 5 is going to hit directly to router 4. So all this time we're killing this link between 3 and 5. Router 4's loopback is like, I don't really need to change at all. So that's why its sequence number has stayed at 1. Because it's happy. It's not affected by any of this. He's kind of like that old guy sitting at the bar drinking. The bar fight breaks out, and then he's still drinking. He doesn't care. He's just watching the carnage. Everything's the same to him. Okay. So that sequence number is tracking how many times it has changed. So things have gone down, better metric, maybe I've disappeared completely, you know, stuff like that. So let's go back to R2. Now we're still on R2. So show IP route OSPF. Now if you look at all of these routes, you see that the next hop, what do you notice about the next hop? It's all 10, 10, 12, 1. And that should make sense, because if you're R2, the only way you can get out is through R1. Right? R2, the only way to get out is through R1. Let's take a look at R1 stuff. Show IP route OSPF. Now R1, everything to get out to another area is through 10, 10, 12, 2. Okay, well this is actually going to R2. So if you're R1 going to R2, everything's 10, 10, 12, 2. If you're going to area 0, everything's 10, 10, 13, 3. Right, so if you're going to any of that, the next hop is 10, 10, 12, 2. If you're going for any of that, next hop is going to be 10, 10, 13, 3. So let me ask you guys a question. If we show IP OSPF database, and we see all of these summary network link states, you're going to get one for every link outside of your area. But R1 only has one way of getting to the outside area. Does it make sense for me to keep all of this information? I mean, if we look at our diagram here, does it really make sense for R1 to have all of those summaries to get to like the loopback of router 4, the loopback of router 5, the loopback of router 3, basically everything to the right? Does it make sense for me to have 20 entries when there's only one way for me to get out? So 10, 10, 13, 3. That's really all I need to get to. What do you guys think? Yeah, it doesn't make sense, right? So what I can do is I can group up this area, group up area 2. And in this case right here, we're going to do what's called we're going to do a combo. So we know we want some type of like a default route of getting out. Now I could, if I wanted the work, I guess, I could go on R2, make a default route to R1. R1, make a default route to R3. I could do that. I could put a default default information originating on R3, do a couple other things, but here I'm gonna do a combo thing. I'm going to stop stuff, extra junk, from going into area 2, which is on the left side, and I'm also going to give him a default route, basically saying if you need to get out, you're going to hit me, go to R3. Yeah, everything come this way. Go this way. So really easy way of doing it. I'm going to go on R3, go back into router OSPF 1. And we're going to say area 2, you're going to be a stub area. So area 2, you're going to go area 2. And if you do a question mark, you'll see stub and all this stuff. But easy way is just say stub. You're basically saying this area is the end of the line. There's only one way of getting out. Now there's other stuff that can go beyond that. You could do area 2 stub no summary, which we will get to in a second. So just keep in mind, if you type a question mark, there's stuff there. But we'll type in area 2 stub. Now as soon as you do that, your neighbor dies. Neighbor 1 goes down. And the reason for this is all the routers in the same area must have the same stub setting. So you set one side to stub, the other side's got to be set to stub as well. So you see neighbor is down, neighbor is down. So let's go to R1, conft, router OSPF 1, area 2 stub. Wait a couple seconds, neighbors. Okay, so neighbor now pointed to R2. It's going down the line to the left. Things are dying. But on the right side, router 1 and router 3, they're back to full. So let's keep going left. Our last one down the line is router 2, router OSPF 1, area 2 stub. Yeah, look at that. Things are happening. Probably should have taken that debug off, but that's okay. Alright, so we changed area 2 into a stub. Let's see if it actually got us anything. Holy cow. Yeah, so OSPF, you could see how if you have an older router that doesn't have as much CPU, OSPF may not be the right protocol to run if you have lots of routers. Remember, our topology here, it's just 7 routers, and OSPF's only running on 5 of them. Okay, so after all of that's done, let's see if this got us anything. Show IP route. Well, I still have the IA routes, but at the bottom you'll see that you got a what? That all zeros route. That sure looks like a default route to me, right? It's a default route. It's given to you by OSPF. All it basically says is, hey, you want to go out? Head out towards router 3. So when you did this, your ABR is acting like a magnet. All right, so this area you turned into a stub. Think of it as everything is being pulled towards router 3. You've just popped a big magnet on router 3 and you're pulling everything towards it. And then router 3 somehow is going to get you out to the correct stuff. Router 2 and router 1 going to fling all of its traffic that it doesn't know how to get to towards router 3. But you see that it didn't really take care of our IA problem. So we're still getting all of these inter-area routes. So you get the LSA. Yeah, we'll just verify that. Show IP OSPF database. Summary. So just show me the summary LSAs. That's the type 3s. So you're still getting them. And you can shorten this up. If you show IP OSPF database summary, pipe I, and you could probably do link. Okay, we could shorten that up a lot more. Link state. There we go. Okay, so show IP OSPF database summary, pipe I, link state. Then it's clean. I like this output because if you show IP OSPF database summary, it's ugly, right? You don't want to expend more brain cells than you really need to. So our goal right now is to kill all of that. It's unnecessary. We don't need it. Because why, if I just have a default route, I just need to use that. And you guessed it, if we go back to R3, hit the up arrow, so there we have area 2 stub, do the question mark, it's telling you no summary. That sounds kind of weird. You may be thinking no summary, so it's not going to do a default route. Here summary does not mean default route. Summary means summary LSA. So make this into a stub and don't send type 3 LSAs into there. So watch what happens. Hit enter. Go back to router 1 or 2. Or actually go back to 1. Router 2's debug is still going. So now if you show IP OSPF database summary, pipe I link state, you got 1. Default route only. You've just killed all the type 3s coming in. Right? And it's the same thing on R2 as well. So you just cleaned out your LSAs, your summary LSAs, which in turn also kill the OSPF inter-area routes from your routing table. So basically you've dumped a whole bottle of Metamucil into your routers, cleaned them out, and now everything's squeaky clean. Now remember when we first did this area 2 stub, we had to go on all the routers to do this. Area 2 stub on router 3, area 2 stub router 1, area 2 stub router 2. This no summary command, you just put it on the ABR. So why do you think we only do this command on the ABR, router 3? Why is it not necessary on router 1 and 2? No type 3s yet. So if you killed the type 3s on router 3, there's no more type 3s on router 1. So it makes no sense to start killing them down the line. Also, the type 3s are only made at router 3. So you're killing them at the source. Right, so we don't need area 2 stub no summary everywhere. Just need it on the ABR. Okay. And we're going to finish up with this. So we saw before when we killed a link, our spanning tree goes nuts. Now we're summarizing everything. We're basically cutting out a lot of the fat coming into area 2. Now I still have that debug running on router 2, so that's good. We're going to go back to R3. We're going to cut the link again and see what happens. And this will probably shock you. So we're going to go do show IP interface brief. And it's going to be the link between 3 and 5. So interface fast 10, shut. Shut that puppy down. We know that R4 is going nuts. R4 is going nuts right now. Look what's happening on R2. Absolutely nothing. So if your area 2 is on a satellite connection in a war zone in the middle of Iraq, you are happy because you don't need to know about all the network outages in Europe or US or anything like that. You're happy. Your link doesn't need to come up. Your routers are your ruggedized routers that probably don't have very high CPU, not a problem. So does that make sense to everyone? One of the big reasons to use multiple areas and to use stubs is to hide the information, is to hide the craziness that's happening in other areas and to hide it from going into your area. I have never been in Vietnam yet. One of these days. Okay, I think we're going to end it now because it's coming up on 7:45. Any questions before we cut this one off? Okay, so Jerry has a question. So stub is used for summary purpose. So you get a summary when you do a stub, but that's not really the primary purpose of why you're using stub. So the reason you're doing a stub is you want to stop information going from one area to the other. The reason we're doing this on the left side, so the reason we pop this guy as a stub, whoa, that was bad. Okay, so the reason we pop this guy as a OSPF stub is because the routers in here only have one way of getting out, right? There's not some other network over here. So if you only have one way of getting out, I want to lessen the LSAs coming into my area. And by doing that, I lessen my CPU load. Less information, less load. Okay. Another way to put it is you probably know people out there who are project managers or managers. They have to keep track of a lot of things in their head. This project has this deadline. This project has that deadline. You're keeping track of 10 projects in your head. After a year of doing this, you'll see that they get gray hair and they're starting to look a little old. Versus, let's say a guy who's a very lowly, let's say a janitor or whatever, right? Not a lot of responsibility, doesn't have to keep track of a lot. They're completely in the moment. That guy is probably not going to age that much. Now, assuming not a lot of manual labor, all that, but the less things you keep track of in your head, the better off you'll be. And in this case, it's the same thing, but for OSPF. Now, the side effect of killing the LSAs is it makes you a default route and stops other routes from coming in. So always look at it from the perspective of you kill the LSAs first, and then you kill the routes that are connected to those LSAs. Right. Another way of putting it is, yes, more George Zimmerman stuff. It never ends. Okay. So this is Google Maps. This is a picture of Southern California. If I want to drive from my place to Las Vegas, I take this road over here, through Barstow, through Victorville, all the way up here. Right? And the reason I decided on this route is because I looked at this map. You can consider this map as my LSA. Everyone gets the same LSA. Everyone gets the same map. Now, how I pick my way of getting to Vegas is going to be different than a person living in Los Angeles. Okay, so this map gets me to Vegas. Now imagine, I've never been to Vegas before, and imagine I get a map where this road isn't even here. Right? Poof, it's out of existence. This road does not exist anymore. We'll consider that the LSA that has been killed. Well, if that's no longer there, I can't even make a route through that guy. I have to pick something different. I have to go to the right or wherever. How would I get there without that road? That would be ugly. Jesus. I guess I'd go up here to Bakersfield, cut across, and go that way. Or through Phoenix, yeah. Yeah, I'd go through here and come up, and yeah, that's another way. Yeah, yikes, huh? So the LSA in the route, they're linked. But LSA is killed first, you don't even get the route to go there. It's kind of like a trickle-down theory. All right. And understanding this is the difference between going to a CCNA Academy, where they just say type in area 2 stub. Done. End of story. Versus knowing something like this and knowing why and how to do it. Okay. Any other questions? All right. So next week we're going to be doing some redistribution. The topology that we're going to load in next week, I'll give you the .NET probably Saturday and Sunday. It will have all the OSPF already up and running, right? So you don't need to type that again. However, for those of you guys who are just starting, I would suggest that you play with this IP address topology, the 7 routers with just IP addresses on there. Practice putting OSPF multiple areas on them once a day. That way you get kind of used to it, and that's how you're going to get faster. Right? But for next week, I will give you a topology with everything already set up, so you don't have to worry about that. And like always, I'm going to edit this video. I'm going to cut the dead times out. It'll be uploaded and ready in about 3 to 4 hours, so you can review and watch it over again. Okay, we are out of here. Thanks for coming, and stay tuned for next week for part 4.